Well, the time has come, I guess, to finally get around to the inevitable printing decimals. So before I might have mentioned a technique where you go, let's say we got 43605, yeah, where you go. Is it greater than 10,000? And then you go and grab that out of there, and then you go, is it greater than 1,000? And then grab that out of there, and then is it greater than 100? But there's another way to do that where we're going to use division. Okay, and basically you take that value and you divide by 10. So what would be the result if I divided by 10? It would be that. Yes? Okay, so that then I can just grab that out of the remainder. Yeah. And then we'll divide by 10. And, well, grab that out of the remainder, print it, divide by 10, etc. And then when the quotient no longer returns, when it returns 0, end of loop. There. So that sounds relatively straightforward. We're going to need a value then. What did I say? 4, 3, 6, 5. That's pretty good. 5-digit value. Because what's our max? 65,535 that we can store in a 16-bit value. That's also 65,535 is the maximum value you can do in divide in do division on in 16-bit too. We will be dividing by 10. We're going to be working in 10. So yeah, interesting thing about that. Let me just go back to what I was doing there. What did I say? Got a value, right? You recall before we did the remember shift left and shift right, where we got 0 1 1 0 0 1 1, right? And you go shift left, right, and that effectively multiplies by 2, right? If you go shift right, then that divides by 2. Right? So when thinking in decimal, same thing. If I go multiply by multiply by 10, that's the same as shifting left in decimal, you see. Or if I divide by 10, that is the same as shifting right in decimal. Likewise, while we're on that train of thought, if we're working in power of 16, as we would be in hex, since 16 also divides by 2, I could shift left 4 times, and that is the same effect as multiplying by 16, you see, or shift right is the same as dividing, right? Which, yeah, that can be useful because, everything A, B is thought of in hexadecimal values because that's convenient for memory and everything. Big, large groups of data can be stored in maximum 65,535 bits. Okay. Enough elaborating on that. Here I am still waffling. I guess I have a phobia about this printing values to the screen thing, probably because I've sat through way too many programming books where the author was obsessed with, printing countless arbitrary values, when I was just wanted to know how to make a pong ball bounce off a wall, you know what I'm saying? So let's get on with more of that, shall we? Let's see, I'm just gonna lose all that for now. I gotta keep that bit there. So we will handle things a little bit differently. Here, cut that out of there. We'll put it, say, down here, I believe. Let me see. Yeah. Okay. So we'll declare our initial value up here at the top, and then we will call our print decimal program. Print decimal program, which we haven't created yet, and some of this will be used in there, I guess. So let's create it, I guess. Print decimal down here. There is our print decimal, and it will return down here at the end of everything, I guess. So first thing we're going to want to do, we're gonna iteratively work through the value stored in here. So first we should probably create a backup of it. We're going to push AX. Yeah, that's all we got to do. So now it's on the stack. Then we will use CX to keep track of how many digits there are in total. So let's create a counter for that. That would be XOR CX. There we have initialized our counter. Great. What else? Right. This bit here will be initialized there. So that will be our divisor. Yeah. Constant, I guess. Yeah. Okay, so we're going to create a loop, I guess, and let's use that dot technique. Divide by 10, and it'll be a loop. Yeah, so might as well go ahead and say that right off the bat. We're just gonna roll through that loop until it reaches 0. Jump not 0 to our loop. Oops, divide loop. There we go. Like so. Okay, so inside there, we're going to do all of this for one thing. Well, here, let me tab that in. There we go. Divide BX. Let's see. Then we will grab the remainder. So we're going to do some division. Here's our value in AX, right? And then down here when we call the print decimal, it will take the value in AX, and then we're going to do some division on it. Yeah, and then here's the thing: we're going backwards. We're going 5, and then we're grabbing 0, and then 6, and then 3, and then 4. So we need to store all that onto a stack, I guess, so that we can grab it all back in reverse order. Okay, so even though we already have one thing on the stack, we're gonna throw some more things on top of that, and then at the end we'll grab that back, and the stack is all clear again. Okay. Push. So we're going to push onto the stack, as I just explained. DX. Yeah. So we're grabbing the remainder and saving that as a single digit on our stack. Okay. And once we do that, we want to keep track of our count. Our counter that tells us the size of the stack, keeping track of the total size of the stack, so that when we reach the end, when we get to 0, that is the end. Okay, and now we want to test whether AX has a value of 0 or not. That's all we got to do. AX, there we go. Divide 10 loop. Wonderful. So then one last thing. Now we got that. We're going to unload the stack, right? So basically, we will create another print stack loop, which it will use the value here that we stored in CX as its counter. So that means we can just go loop this. Yeah, like that, right? Yeah. And then when it reaches the end, when CX equals 0, it has finished grabbing everything off the stack except AX, which was the first thing we threw in there. Wow. Okay, so loop print stack. We want to pop the value that we have stored on DX. That's it. And then let's see, move the ASCII digit to AL. Move into AL, DL. Oh, yeah, okay. So we're taking the here. We just grab this, right? Now we want to get the bit that's printable and put it into the printable register. There, simple enough. Excuse me. Call the offset. Let's see. Have a print stack pop DX. Oh, I'm sorry. Here, this should all actually be in there. Yeah, and let's just tab it in there. All right. Let me see what all I'm messing up here. What do you know? I didn't mess up anything. It worked. Oh my God. Buy a lottery ticket, folks. Great. 6. There's our value. No, it's not. It didn't work. Hang in here. What did I do, folks? What did I do? I've been working the whole time. Bad me. I've been working in a folder called division. Let's go find my test. Remember, always save your where are we? Assembly test. Okay, there. AV. There's our file. Let's save it. Now we'll see how much I messed it up. I got a 5. Okay, what's going on here? I do not have a full loop. Why is that? What exactly do we have going on here? Divide 10 loop. XOR DX. Divide BX. Push DX. Inc CX. Test. Yeah. Jump. Okay, looks good. Print. Stack. Pop DX. Move AL. DL. Call. Offset. ASCII. There it is. Here's the problem. Call this, call offset ASCII, okay, and then we're going to loop back, wait, call offset ASCII, oh, I see, here, got it, needed to do that, I didn't call the printout part, okay. And pop. And at the very bottom, one last thing. We still have AX in the register. Pop AX, returning us back to where we left off. Womp when we type return. Okay, let's see what we got. There it is. Marvelous, the previous one. Fortunately, I used a different number on the dry run than I did on this, so I noticed right away it was actually the file from before. But there, we got that working. We can now have all kinds of fun printing boring values to the screen, right? Print decimal. Very useful. Okay, let me just, what are we doing here? Back up if AX. Oh my God. Did you hear that? Sorry. I can turn that off in the OB1 OBS Studio. What are we doing? Clear counter, stack counter, we'll call it. Let's be specific. We're going to count our stack. This is a constant, really. Constant to divide by 10. Okay. Initialize our when we do remainder division division remainder. Yeah, okay. Divide AX by 10. There we go. Store on the stack. Yes. Stack counter. Check if anything is left. If it's 0, then we're done. Exit the loop. Okay, what do we got here? Print stack. Pop dx. Okay. Yeah, print stack. So pull values. Which values were they? Printable. What? Well, decimal. Pull decimal values from the stack. Okay. Move to printable register. Yeah. Yep. And then of course print it. Yep. And keep doing it. Do it till CX 0, whatever. Great. There. So when we at the end of all this, we read whatever is in AX. There, we do a bunch of stuff to it, but then we put it right back. So we have read it and restored it to its original value here, return, and we all know what this does, and that is all she wrote. That is how to print a decimal to the screen.